Hello folks, how are you all doing? Welcome to Introduction to Cloud Computing with AWS. I am Muthukumar, instructor. Alright, can I have quick confirmation? Someone can give confirmation on audio. Am I audible and clear? Hey, good morning Mehul. Yes, thanks. Thank you. Hey Ishwar. Yeah, we're a little late by a couple of minutes, that's okay. Alright, I was waiting for people to join. Okay, let me introduce myself. I am Muthukumar. Having around 13 years of experience and 3 to 4 years experience in cloud and big data. Okay, this is the 1 hour introduction session about cloud computing with Amazon Web Services. Today I'll give introduction about what is in Amazon Web Services and how to use and how it's being used in the market. All right, okay, let's get started. So it's a live session, and generally how it goes, Amazon Web Services is a 24-hour session. It goes for 8 days, that's 3 hours each. It's an instructor-based training, and you will get 24/7 class support. Even after the class gets over, you will be getting the support. And every session, you will have a demo associated with that particular session. After the session, you will have some hands-on. And every session, the session that's being conducted, it will be recorded and it will be uploaded into the LMS, that's Learning and Management System. Okay, and you will have access to it. This particular session is for 1 hour session, and you will have introduction. And considering the fact it's a 1 hour introduction session, we have a Twitter handle where you can, if you have any questions, you can post it the Twitter handle with the tag Ask Edureka. Our support team will be in a position to answer your queries. Okay. And in the meantime, this 1 hour session, if you have any questions or clarifications, what I would recommend, you can note it down. At the end of the session, we will have the question and answer session. Okay, considering the fact like we have more number of participants, that would help us so that there will not be any disturbance in the flow. All right. Okay. All right. So the objective for today is to understand what cloud computing is. What are all the, when I say cloud computing, the attributes, what are the attributes it should have, what are the different service models we have in cloud computing, and different deployment models as a part of cloud computing. Then we will get introduction to Amazon Web Services. Amazon Web Services is infrastructure as a service, basically. They give cloud deployment model as an infrastructure as a service. Okay. And few typical use cases where Amazon Web Services is being used, and various service offering within Amazon. There are almost like 50 to 52 services we have. I think 45 to 50 services we have within Amazon. We will see few introduction about those services, where and how that is being used. And I'll try to show you a simple demo how we can make use of Amazon Web Services. Right? Okay. All right, let's get started. So this was the statement from some microsystems. Okay, it's a very good statement. That's the reason it's put over here. We believe we are moving out of Ice Age, Iron Age, Industrial Age, the Information Age to the Participation Age. Okay. I'll explain, like maybe I'll give some analogy and explain what this Ice Age, Iron Age, Industrial Age, Information Age, everything. You get on the net and you do stuff. You blog, you take pictures, you publish, you podcast, you transact, you distance learn, you telemedicine. You're participating on the internet, not just viewing stuff. Right? We build the infrastructure that goes in data center that facilitates participation age. Now, if you look at the era, how it evolved. Initially, like when we had mainframe model, the days when computer was invented, we were using them just to reduce our time, the calculation time. Okay. Whatever that needs to be, it's going to take say 2 hours to do the calculation manually. We want to reduce that to 2 minutes or like say 3 minutes. Only for compute purpose we were using it. Then later we will start using it for organizing the stuff, and then for communication, like when the client server evolved, we wanted to communicate one and with the other people. We wanted to communicate. Right. Then we got into the information age, or I should say that's the web era. After 1995 or around 2000 to 2010, we were in information age, where lots of information were being gathered, were put in public as a blog, and people were reading the stuff. The information was being shared. There was like huge amount of information being shared across over the internet. I should say that's the internet era. Right now, we are in the participation age. Everybody is participating, not only human beings, even machines, sensors, satellites, everything is trying to, it's tsunami of data we are getting it. Like huge amount of data flowing into the system, and everyone wants to monitor the data, store the data, process the data, and try to get some business out of the data. Right? The information what we are gathering or in this participation age, whenever you do something in Facebook, one simple example I can tell you, Facebook, by anyone who is having a profile of 2 years, okay, there was an incident in US, someone filed a case saying, okay, have account with Facebook, I'm eligible to, I'm entitled to know what all information you are storing about me within Facebook. And you won't believe Facebook sent information almost equal to 2,700 pages of information about that particular personality. Okay, so within 2 years they could collect that much amount of information. So that when I say that huge amount of massive amount of data, I'm with 1 billion users, if I'm going to store that huge amount of data, I need to have a storage where I can store huge amount of data. Now we are talking in terms of petabytes and exabytes, right? 1 petabyte is almost 1,000 terabytes, right? And normal desktop like or any high-end systems, we can go up to 4 terabytes or 5 terabytes, a maximum like very high-end storage, we can go up to 20 terabytes. But beyond that, if I want to store or process like say 500 terabytes of data, I need some storage where I can store that much amount of data and process them, right? So the next challenge coming is the processing part of it. So to process 5,000, say like 500 terabytes of data, you know how much time it's going to take? It's massive amount of time it's going to take. One simple example, let me give you guys. Say for example, you have 1 kilobytes of 1 kilobyte data, okay, each record of 1 kilobyte, and you have only one system. Okay, no parallel processing, you have only one system to process, and each record, this is just an analogy to understand how much amount of compute power we need and what we need to do. Okay, say at every second you can process almost like 1,000 records, and if we have to process 1,000 records per second, okay, and each record is 1 KB, you know how much time it's going to take to process 1 terabytes? It will take 277 days, and if it is 1 petabyte, it's going to take 785 CPU years. I cannot wait for that huge long, right, for generation to process 1 petabytes of data. Then the only option I have is parallel processing. I need to go for multiple systems, say hundreds or thousands of systems working parallel together, and then get the things done, right? Like parallel processing or like a cloud computing. That's what's called cloud computing. Okay. Now, when I say now, there are two challenges over here. One is storing huge, massive amount of data. Another one is processing that huge, massive amount of data. And if I have to store that huge amount of data, and if I have to process that huge amount of data within my own infrastructure or within my own premise, right, I have to have huge amount of infrastructure upfront ready with me. And you know how much time it's going to take to procure the hardware, harden the hardware, get it up and running, right? It will take huge amount of time. Excuse me. The same thing if I go with the cloud, say Amazon Web Services, within few minutes I can get a machine of any size I want, and I can get any number of machines within few minutes. I'll show some demo on that front as well. Okay, so that's the two challenges we are going to solve with the cloud. The first challenge, we will see how we are going to solve the problem of the compute, the huge and massive amount of compute, how we are going to solve. Then we will see how we are going to solve the huge and massive amount of storage. Okay, and now you would have heard about this term SMAC, SMAC. It's called Social, Mobile, Analytics, and cloud. The reason why I'm saying and cloud is going to be the base for all these three pillars. Anytime you develop a social application or mobile application or anything for any analytics, you have to go with cloud, right? Anything that anything we wanted to handle with more number of machines, cloud is the best option. Okay, all right. Okay, before going to the next slide, I'm seeing some questions. What I'll do, I'll take the questions at the end of the session. I have a separate time allocated for the questions and answer session. I'll take it at the end of the question answer sessions. Okay. If you have any questions, you can note it down or you can post it in the question panel. I'll take them one by one. Okay, so that there will not be any disturbance in the flow. Yeah, thanks, Mehul. Thanks. Okay, this is the formal official definition from Forrester. What cloud computing is. A form of standardized IT-based capability such as internet-based service, software, or IT infrastructure offered by a service provider that's accessible via internet protocols from any computer, is always available and scales automatically to adjust to demand. Okay, every word I'll explain is either pay-per-use or advertising-based. Has web or programmatic based control interface and enables full customer self-service. Now if you look at it, each and every word, each and every term over here, it makes lots of sense. Okay. Okay. Okay, here. Okay, let me take this word, okay, via internet protocol. I should be in a position to access any infrastructure or any services within Amazon Web Services over the internet. As long as it's available over the internet, then I should be in a position to access it from anywhere at any point of time, and it will be always available. When I say scales automatically, this is a very beautiful statement within Amazon. Let me just open this. Okay, any problem that you wanted to solve, right? We need a compute unit. Any compute unit is made of a processor and some amount of memory and some amount of storage. That's like a hard disk. Okay, so consider this as a compute unit. Now to solve any of your problem, I can go and hire any size of a compute unit within Amazon. When I say any size, assume you have one processor and say like 2 GB of RAM and 20 GB of hard disk. Now at any point of time, I can increase the size of this system. Okay, this is called vertical scaling within cloud terminology. This is called vertical scaling. I can increase or decrease the size of the particular system, but this will have some limitation. When I say limitation, beyond some limit, I cannot add some memory. Maximum memory what it can support is almost like 240 GB per system. Okay, 240 GB is really very huge, but beyond 240 GB, if you want to go, definitely like in single system, we cannot go. To solve that particular problem, we have something called, okay, let me copy this, have something called horizontal scaling. What you can do, you can keep on adding more and more machines dynamically. Okay, I can keep on adding more and more machines dynamically parallel to each other, and that's called horizontal scaling. I can have hundreds of machines or thousands of machines, and I'll pay only for what I am using it. One simple example I can tell you, say for example, few days back, Flipkart, they started their own Big Billion Day or the election results announcement, right? You won't know how much traffic you are going to get on that specific day, right? What I can do, if I were in cloud and if I am using Amazon, I have something called auto scaling. Automatically, depending on the demand, what I have, right? I'll have load balancer here. Have a load balancer, and every system will get attached. Any new system that's coming, it will get attached to it. Say for example, at this point of time, if more traffic, if it is coming, what I can do, automatically system will detect and it will keep adding more and more machines parallel to each other, and it will start serving through the load balancer. And at any point of time, if it identifies, okay, not that much load is happening, say it's like midnight or something like that, or offer got over, automatically it will destroy those instances. Okay, so that you will reduce the cost as well as you will optimally use the resources, and whenever there is a demand, on demand you can increase the capacity of the instances. Right? This is called horizontal scaling. There's a lot more into it, and we have a dedicated session for it, like it's a 3-hour session, and it'll be difficult to discuss the complete thing within the 1 hour time. I'm just giving you a high level overview of how things happens. Okay. All right. This is called horizontal. Okay. All right. Let's get on to our slide. And that's called scales automatically to adjust to the demand, and it's either pay per use or advertising based. When I say pay per use, here if I'm using 3 instances the night, I'll get charged only for these 3 instances, and anytime if I add another instance, when I say instance, like it's a machine, you can consider it like a virtual machine that's getting added in the cloud for you, which has a processing capacity, memory, and a storage. Okay, now the billing will be based on whatever that you are utilizing. Only on that basis the billing will happen. Okay, and another one has web or programmatic based control interfaces. Amazon Web Services, everything, either your compute or your storage or your security system, anything that can be controlled via web. We have a control panel like this. You will be getting a control panel like this. All the services can be managed through this, or you have APIs exposed. You can make the programmatic call through the API and you can do it. It supports almost like 5 languages like Java, Python, PHP, .NET, Ruby. So we have SDKs with all these languages. You can develop programs and we can control these web services programmatically as well. Okay, all right. Okay, yeah, I am seeing some questions. Aishwar, Kamlesh, I'll answer the questions, or like, okay, quickly I think I can answer. We can't go after 250 GB vertically. Yes, Aishwar, that's true. There's a limitation. 250 GB vertically in one single system you cannot go. Okay, and another question, Oracle Exadata or AWS is better. Okay, Aishwar, that's the limitation. And if, for example, if you have a server within your own any system, right, the RAM, whatever that you are adding it, right, it will have some limitation, right? That's what they have designed with their own VM. Vertical scaling, one single system, you cannot go beyond 240 GB. Okay, it's already pre-built. Those instances are pre-built. Amazon EC2. Okay. If you okay, another question from Kamlesh, does horizontal scaling it's called scrolling, Kamlesh, it's scaling has any limitation? No. Okay, all right, there is no limitation. You can go any number, and depending on how your application infrastructure handles. Okay, and to quickly to go to answer Aishwar's question, say you have the instance types you have, okay, various instance types, and how much amount of memory each instance will have, and what is the pricing against each. Say for example, here 244 GB. If you go for i2 8x large, you will get 244 GB of RAM and 800 SSD, 800 GB of SSD storage. It would cost $6.8 per hour. Okay, these are all the pre-built thing they have. Okay, horizontal scaling means adding new pieces. Yes, exactly. We call that as instance in Amazon Web Services, Aishwar. Okay, that's called horizontal scaling. Whenever you need more capacity, you will be going for more number of instances rather than increasing the power of one single system. Because if you have more systems, you can balance them, and the probability of the failure as well, like there are a lot more things involved in terms of high availability, architecture, everything, with multi-region, multi-zone. There are a lot more things involved. What I can do, I can run 2 different systems in 2 different zones, so that the even if one system, one zone completely, if it goes down, your application will be up and running in another zone, so that there will not be any disturbances happening, right? Okay, so that way I would always recommend to go for horizontal scaling than going for the vertical scaling. Okay. All right. I hope I answered your question, Kamlesh, Aishwar, and Mehul. Is Oracle Exadata or AWS is better? I mean, it's like it's asking a question like Mehul, whether Windows or Linux is better, right? Okay, so I may not be in a position to answer that. Each one is having their own features and their own advantages. Okay, after going over the services, depending on which suits your requirement, you can go for it. Okay, as far as I have seen with the statistics, AWS is the market leader, and they are leading the show. A huge amount of market share what AWS is having. Okay. So based on that comparison and your business requirement, you should be in a position to identify. Okay, from when AWS is existence, AWS started its journey around 2004 or 5. Ashwa, they started with a simple storage service, and from then they started. All right. Okay. All right. Okay. I'm start getting more and more questions. What I'll do, I'll from here let's proceed with the PPT and take the questions at the end of the session with, doing the question panel. Okay. All right. Okay. So we have discussed this, and enables full customer self-service. When I say self-service, customer should be in a position to start the instance by themselves. Okay. It should not depend on calling the support or like waiting for like hours or days. No. I'll show a demo as well. Okay. And cloud computing as such, this is something like say 5 blindfolded men. If you ask them to touch the elephant and see what they're touching, depending on what part they're touching, they'll say, okay, it's a wall or it's a rope. Who is touching their ears, they'll say it's a fan, right? It depends on what problem they're trying to solve with the cloud. One simple example, if I say whoever is using a Dropbox or the cloud storage from the mobile, they'll say cloud is for storage. Whoever is using a big data for analytics, they'll say cloud is for a huge amount of computing. Okay, and I can have a separate network, a dedicated network, a storage and processing, different stuff within. So it depends on what problem we are trying to solve within the cloud. And it's not only storage and compute. There are a lot more things involved within cloud computing and within Amazon Web Services. This is the Gartner hype cycle. This is for year 2013. I guess we have not yet got the 2014 cycle. You can look at it, any technology, it will reach the peak, then it will come down, then it will reach a plateau. Okay, this is like a stabilization period or something. You can see, yes, infrastructure as a service, it's already reached the hype and it is reaching the stabilization period. Okay. Another thing that you need to note down is cloud security frameworks. Within the cloud, security is the major concern as of now. Okay, I won't say it's like a concern. Everyone is having that fear or myth saying, is my data safe? Yes, data is safe. Everyone is using cloud. All big organizations, they started using cloud, but still the frameworks is yet to reach the maturity. Okay, still a lot more things going on. Still, comparatively, it's a new technology, right? Only 2008 or 9, they started introducing this virtual machine, virtualization, everything started happening. And cloud, as such, the security, it's yet to reach the maturity to say like, yes, 100% safe and to give some guarantee, right? So that's where it is now. By 2014, I'm sure like it would have reached some peak, but this is the graph of 2013 for reference. All right. This is a very huge and beautiful slide. Generally, in the normal session, we used to take around an hour to explain this complete slide. But let me give a quick introduction what this slide is about. Okay, any attribute, any cloud computing, it should satisfy these 5 attributes. Broad network access, it should be accessible from anywhere. Rapid elasticity. Elasticity is about increasing the capacity positively or negatively. See, as I explained over here, I should be in a position to increase the capacity or decrease the capacity as well, right? Both way. This is the elasticity. I can increase or I should be in a position to decrease. That's the elasticity. Measured service pay as you go. The moment I stop this instance or kill this instance, I should not get charged. And I should get charged only the moment I start a new instance. Okay, till the time I should not get charged. That's the pay as you go model. On-demand self-service. I should not depend on the support team or someone waiting over the phone saying, okay, raise a ticket and start a new instance or new machine. I should do it on my own. Right? That's on-demand self-service. And resource pooling. Simple example I can tell you. Give me a minute, guys. Let me have a glass of water. Thank you. See, resource pooling is, for example, if you want to store a huge amount of data of almost like 500, say 500 terabytes of data, no single system can handle it, right? We have to have some mechanism, but I cannot split it. I should not expect the user to split the or divide the slice the 500 terabytes of data and store it separately. Right? I have a storage service, something called simple storage service. Each object I can store up to 5 terabytes of object. I can store any number of objects. When I say any, it's like any volume, whether it's petabytes, exabytes, whatever it is, you can keep storing. As long as whatever the volume you are storing, you will be getting the charge depending on the volume. Okay, this is about the resource pooling. And for example, compute within the compute, whatever the processor, they'll make sure they're optimally utilizing the processors so that the cost also is going down, and it could be very well possible 2 or 3 tenants sharing the same processor internally, but data is safe. Processing wise, it could be physical processors that's lying on actual physical processors, they could be sharing it. That's about the resource pooling. This is how cloud they were in position to offer a very good discount, or at lower cost they were in a position to give the compute power as well as the storage or processing. Okay, that's about the attributes. When I say service models, there are different service models. These are all the 3 major service models you would have heard about. Okay, software as a service, platform as a service, or infrastructure as a service. When I say infrastructure as a service, Amazon Web Services falls under infrastructure as a service. I'll get infrastructures as a service, say a compute unit or storage or network, complete network, or desktop. I can get a desktop over there as a service, any number of desktop, say 5 desktop or 10 desktop or 20 desktop, whenever I need, I can get it. The complete infrastructure I will be getting it. Platform as a service, it's a little above the infrastructure. After getting the, for example, say I am getting 3 computers over my cloud and I am connecting it over the network. Okay, they are interconnected. And just drawing a simple diagram. Okay, the diagram doesn't make sense. Sorry about that. Okay, so assume these 3 computers are connected over the network. Okay, this is in AWS. I can get infrastructure as a service. Now, what I can do on top of this? Okay, let me just. Sorry. Okay, on top of this, I can install or provide some runtime environment. Okay, I'll give the control to Amazon saying, I don't want a plain vanilla machine, not just a Linux machine. I want a machine which can give me the runtime, Java runtime environment or a .NET runtime environment. Okay, that's called a platform. Directly there, those options are also available. It's called Elastic Beanstalk. What I'll do, I want to develop or I want a Tomcat environment. Okay, underlying at the bottom of this, on top of this, you will have a Tomcat environment. Okay, underlying all the systems being managed, it will be done by Amazon for us. We don't need to worry about applying the patch or auto scaling the instances. If the system goes down, how to start new instance, all those things, it will be left to Amazon, and all I'll be worried about, I want a Tomcat environment. Or in one single click, I can say I want a .NET environment. Okay, everything else internally, your security configurations, your instance configurations, everything will be set automatically internally, and all you will be getting it at within, like, all this happens within few minutes, right? 5-10 minutes you will get a .NET environment and you can start working on it. Okay, that's about the platform as a service. All right, I'm seeing some more questions. What I'll do, I'll answer the questions at the end of the session. Yeah. Okay. All right. Okay. Okay. Within. Okay. Okay. All right. Guys. Even if you raise your hand, like guys, please post your question. Okay. By raising the hand, I'll not be in a position to answer it like immediately. Post your questions after having a logical conclusion of the slides. I'll answer all your questions. Okay. I'm just putting the hands down. All right. So that's about the service model. There are a lot more discussed in service model. This is about the high level. And software as a service, for example, Gmail is the complete software as a service, or Salesforce. I'll get, for example, webinar is a software as a service, or Dropbox. I'll go get an account. Everything will work, and internally the systems, whatever the patch to be applied, are keeping the systems up and running for 24 hours and handling the volumes. I won't know how much volume I'm going to bring in. Right, everything will be handled internally. All I'll be getting is like an account. I'll be giving it. That's like a software as a service. Okay. On top of this PaaS, and yes, we will be developing a SaaS, software as a service, and we'll be giving it to the public. And anything as a service. Now you start getting like firewall as a service, or database as a service, HBase as a service. A lot of things started coming out. Okay, everything you want to offer that as a service. Okay, and deployment models as such, you have four type of deployment models. Public cloud, that's multi-tenant. What Amazon is giving is a public cloud. Similar to you, how you are creating an account, I can create an account, or any enterprise, they can create an account. So everyone will be working in the same data center. That's the public cloud, multi-tenant. Multiple tenant will be working, and the same hardware, the underlying hardware, the physical hardware on top of it, where the virtual machine is getting created, right? For example, let me just quickly tell you. Assume this is a virtual machine. Okay, say the underlying hardware, you will be having hundreds of hardware, right? It will be virtualized. On top of it, whenever I say I want a new virtual machine, on top of this we will be creating the virtual machines. Okay, it could be possible this virtual machine is created by you and this virtual machine is created by someone else, and they both may be or may not, okay, maybe using the same hardware, or after you stop using this instance might use the same hardware. It could be very well possible. This is multi-tenancy. And again, multi-tenancy is a huge topic to discuss, but to give in high level, this is the underlying hardware. Okay, hardware host machines. These all are virtual machines. Okay, these all are VMs. Okay, what are the VM? Virtual machine you are creating it. Okay, this is virtualization. Virtualization. Okay, right. Now this is how it works. That's about the multi-tenant. When I say public cloud, multiple tenant can come into picture, but there could be some legal requirement or government mandate saying all medical records or insurance personal information should be stored internally. It should not be multi-tenant. Okay, in Europe and US and all, there are some government mandates saying all this personal information should not be stored in public cloud. In that case, I will create the complete cloud infrastructure in my own premise. Okay, all hardware machines I'll procure virtualization hardware, virtualization software. On top of it, I'll be creating the virtual machines, and I'll be working in my own premise. The data will not go out of my organization. That's called private cloud. Okay, hybrid cloud is mix of these two. Always I cannot go for the public private cloud, all the data, right? So what I'll do, I'll have okay. Now, say assume this is the private cloud. Okay, I just I'm not going to draw that once again for the time constraint. I'm just okay. This is the private cloud. The same cloud infrastructure, you can create it in Amazon Web Services as well, right? So assume this is your Amazon Web Services, and this is your own office premise. Okay, this is AWS. This is your office. Okay, enterprise private cloud. Okay, let me put it here. Private cloud. Now, what I can do, I can interconnect these two. I have a separate service, okay, where I can interconnect these two, like a dedicated network or dedicated VPN I can connect these two and transfer the data. Anything that needs to be stored within my own organization, I'll put it in the private cloud. Anything which can go public, right, a small static website or any marketing, anything that I am doing, I can go to Amazon Web Services, and I can have a dedicated network between these two. There are services available within Amazon to do that. Okay, we can connect using VPN connection, and we can do that. Okay, everything, whatever that you going for with Amazon, they give that as a service, and there will be measurable quantity in terms of if it is a storage, how much amount of data you're going to store, and how much amount of data you're going to transfer. Okay, that's called hybrid cloud. And community cloud is something like a private cloud where a group of organizations or group of educational institute, they come together and make a cloud for their own purpose. That's called community cloud. Okay, right. So this is small statistics to show you what's the growth we are having in cloud. Okay, people are expecting the cloud market to be around $240 billion by 2020. Okay, this is the growth what people are expecting. Small statistics to show how the growth could happen. Now let us see in detail what Amazon Web Services. Okay, already I have given some introduction about the cloud, compute, storage, everything. You will see some details. AWS Amazon Web Services, it's a web service for infrastructure as a service. All infrastructures in terms of compute, storage, database, application service, or deployment, networking, everything they give as a service. Anything that I need, I can take it. And they give 1 year free tier with all the services. Okay, I would recommend free tier. Anyone can create an account. Okay, and these are all the things you're eligible. For example, to run a micro instance, it's called micro instance, you can run up to 750 hours per month. That means almost you can run 24/7. Even if you run 24/7, it will not cross 744 hours, right? One instance you can run free of cost for 1 year. If you go beyond this, obviously whatever the charge applicable, you will get charged. And in storage, you will get 5 GB of standard storage free. Similarly, everything you have, EBS is like a hard disk. You can attach it to the system. Okay, RDS is relational database service. You can start managed database, any database you want. Basically 4 flavors they give, any size you want. But MicroDB instance is available for free of cost for 1 year. Beyond that, you will get charged. Okay, and even if you cross this limit of 750 hours of air or 20 GB of storage, anything, you will get charged on that as well. Okay. All right. So let's get on to the slides. And AMI is like a ghost image. Whatever the instance you are starting, that's called AMI. And after, with the ghost or installation CD, once we create a VM, it's called instances. Volume is like a hard disk, and snapshot is complete backup of your volume. You can store it and retrieve it at any point of time, or you can share it with someone. Everything you can do. It's a very powerful feature. Okay, creating an image and creating a snapshot. It's very powerful image, powerful features with Amazon. What I'll do, I'll quickly start one instance. Okay, I have logged in to my own account. This is EC2 is called Elastic Compute Cloud. I'm going to start an instance now. Okay, let me log in. I'm going to take all default features. Okay, in the actual session we will be explaining each and every screen why we are doing what we are doing, but due to time constraint now, I'll be selecting the default values and I'll proceed. Now I'm going to get Amazon Linux that's based out of Red Hat. I'm going to ask for an instance, to create an instance, micro instance. Okay, it will have 1 GB of RAM, 1 GB of CPU, one virtual CPU it will have, and I can add EBS storage, elastic block storage I can add. Okay, only this is eligible for free. I'm going to do that. Here I'm going to leave everything default. Here, what the root device that I'm going to attach, what should be the size? I can have any size up to 1 terabyte I can have. As of now, I'm going to select 8 GB only. Now I'm going to give some tag to it. I'm going to add a security configuration. What I'm going to say, I'm going to I am opening the port 22 from anywhere. As well, I am going to open the port HTTP from anywhere. I'm going to review this and say launch. To log into the system, I need some key. This is a private key and public key pair it will be creating. Already I have a key with me. So I'm going to ask the system so that allow only this particular key. This private key I have it with me so that I can authenticate and get into that specific instance. Okay, so one instance is getting baked in Amazon for me. It will be ready within a couple of minutes. Okay, in the meantime, let's go over the slides and come back. Now, this is the elastic feature, whatever that I talked about. Okay, it's a very beautiful graph where I have, see, the red line is the actual demand of the application. It will keep oscillating, right? And blue line is the typical how we will add the infrastructure to the traditional way of adding the infrastructure. I'll add it, and here I'll have some budgeting session and I'll get new hardware. I'll again add it, right? And here again I'll be adding it. Let me quickly take a screenshot of this. I'll explain. This is a very beautiful diagram. Okay. So this is the blue color one. I have added a huge amount of capacity here, right? A huge capacity I have added upfront to handle for next 1 year or something like that. But you see this particular gap over here. Already I have over provision till this point. It's a opportunity cost. I could reduce the cost over here if I doesn't provide over provision it. The same way here, already the demand crossed my this particular point, right? Already demand crossed my provisioned hardware capacity. So there will be some unsatisfied customers. I'll not be serving those customers, right? I'm increasing the capacity and only at this point. So this is the opportunity lost, right? But if you go with Amazon, the hardware capacity, it will keep growing along with your demand. As long as the demand is increasing, it will increase its own capacity. As long as the demand is decreasing, it will decrease the capacity, like here, 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 right? So that's about the auto scaling. Okay, and you will pay only for what you are using. Here you will pay less and here you will pay more. Only for what you are using, the billing will calculate it and you will be using it. Okay, and Amazon is having different regions, almost 8 regions they have their data centers. Within region they have something called zones. Okay, when I say zone, say New York region, they'll have multiple zones, zone A and zone B. They'll be split separately in terms of infrastructure like electricity or internet, everything, it will be split separately so that the high availability feature we get it. There is no risk across each other. Okay, so that's about the zones. And edge location to deliver the static content, we have around Amazon is having around 52 edge locations. Okay, so edge location is for delivering the static content. And we will be discussing about a separate a service offering. It's called content delivery network, where you will get the content will get delivered very fast. For example, any software patch or anything you want to deliver across the globe for your any mobile app or anything like that, what I can do, I can distribute to all 52 edge locations across the globe, and only whoever is near to that, they will be in a position to access it. Okay, and it will be very fast. And data transfer will be very fast, and latency will be very, very less. So this is what I discussed about. We have around 8 regions. One region is only for the compute, that's for the, sorry, government cloud. It's for the government of US government. Okay, this 8 anywhere we can create, and each zone minimum they'll have 2 zones, so that each region will have minimum 2 zones, zone A and B. For example, North Virginia, they have 5 zones, so that I can create instances in multiple zones and increase my availability of my application. Okay. EC2, as we have discussed, this is the compute unit. This being given as a web service, I can get any size and any configuration, and I'll pay only for the capacity I am using it, and dynamically I can increase or decrease the capacity. Both vertical and horizontal scaling is possible. There are some pre-built AMI. AMI is called Amazon Machine Image, available from the marketplace. Anything like, for example, you want to build an image out of some other server, say Zen server or anything, they are also available from the marketplace, and you can get it. Again, within the types, we have something called on-demand, reserved instance, spot instance. Okay, on-demand is what we have done now. On-demand, I have got one instance. Similarly, I have something like a reserved instance. Reserved instance is like what you use in rate cutter in mobile plans. Right, upfront you'll pay some amount, and further whatever that you're using, you will get discounted price. And spot instance is going and bidding with the available instances. For example, Amazon is having a capacity to create 1,000 instances. I'll go say like Amazon as of now, if it is using only 600 instances, 400 instances, what they'll do, they'll give it as a part of spot instances. You can bid, and whoever is giving a higher bid, they'll get it. Here, most of the time you will get, in terms of 80% discount, you will be getting in spot instances. Again, the disadvantage will be, if someone overbids you, you will lose the instance, and they'll gain the instance. Okay, not the data, only the instance. Okay, EBS is like a hard disk. To your instance, you can add any number of hard disks, and each hard disk you can have a capacity from 1 GB to 1 terabyte. Okay, you can add any number of hard disks, and from the hard disk you can attach a volume. For example, here, right? What I'll do, I'll log into this instance and show you guys a small demo. Okay, this is the public IP address. I'm going to use putty. This is the IP address I'm giving, and EC2 user is the user ID, and here I am using my private key to log in. Already I have created the key. Okay, first time I'm logging in, so it's asking for the verification. Okay, I am into the system now. Now what I'm going to do, I'm going to install a HTTP server, a small HTTP server using yum. I've installed HTTP server. I'm starting a HTTP server. Okay, HTTP server is started. I'm going to edit the index.html. I'm adding this content in index.html. Okay, done. Now, what I'm going to do, I'm going to access this and see what happens. See, a web page is available, a website is available to anyone. I'll share the link to you all. You can, I've sent to you all, you can just verify. Okay, you'll be getting a page over here. Now, the same way, if I want, this is the 8 GB, sorry, 8 GB volume, right? If I want, I can create another volume of 2 GB. Okay, in the zone 2C, I have 2 GB volume. Okay, let it create. In the meantime, we will. Okay, that's the elastic block storage. Is the volume you can create, any number of volume you can create, and you can add it to the instance. Okay, simple storage is like you can assume it like a mass storage, a storage for the internet. Any volume you want to store, you can store it here. We call everything that is getting stored as an object, not as a file. Every object, it can be of size up to 5 terabytes, and you can store any number of objects. So basically unlimited, and you will have full access rights control. Okay. And everything can be exposed through API and SDK. It's very easy to control and access. This is the auto scaling what I talked about, right? Auto scaling, what I can do, I have some feature called auto scaling. Automatically I can increase or decrease the instances. For example, let me just quickly put this. As I explained, the number of instances I can increase or decrease. But how I will increase and decrease? Basically here, right? This particular CloudWatch, there is again a service. I can monitor the latency and utilization of these machines, latency from elastic load balancer, everything. Based on that, I can give instructions to my auto scaling, increase or decrease the instances. Okay, I can increase or decrease the instances automatically. Okay. All right. Now, yeah, I'm seeing some more questions. We're coming to the end. I'll complete this and I'll answer all your questions. Okay. Now, as I explained, we can create any number of instances, whatever that I want, I can do it. But I need, give me a minute, please. Thank you. Now, I need to control them in terms of who can access, who can create how many number of instances, how they can access everything, right? For example, if I am storing some production data in simple storage, I should restrict them to only the QA and the production people. I should not give access to the development team, right? And any instance, if I am running a production server, I should not give access to the development team. It's like accidentally, if they destroy the instance, the whole thing is gone, right? So to control that, I have something called identity and access management. If you look at compared to other cloud providers like Rackspace or even Google Compute Cloud, Amazon is leading the show mainly because of this particular service. It's a very powerful service. They started this very long back, and they have full control on each and every service they are operating. And you can do it with the control panel or through SDKs, and it's free of cost. The management of IAM is free of cost. So this is what it's giving the edge to Amazon Web Services, if you ask me personally. And relational database services. Again, if you want a database, MySQL database of this much size, say 500 GB, within few click, whatever the size you want, you can very well create that. Amazon RDS pricing. Look at this. Okay, any instance type, whatever the instance type, whatever the size you want. Okay, based on that you can create. Again, you can create Oracle. Okay, you don't need to go and buy a license. Licensing cost also involved here. You can start a M3 medium size Oracle instance, right? And you will end up paying only 21 cents per hour. For example, any production test you want to do in your QA environment, any test you want to do with the real actual Oracle database, you can very well do it. Run it for 2 days and pay only whatever the cost involved and destroy the instance. You don't need to go and procure Oracle license for this. Right? This and even SQL Server, we have Postgre, everything is available as a part of RDS. This is called Relational Database as a Service. We have 4 flavors: Postgre, MySQL, MySQL, and Oracle. And all the applying the patches and taking the backup, it gives the option to take a backup, user-defined retention period. Anything, any amount of time you can retain the data, and it enables point-in-time recovery. Any point, like you want to recover the data, you want to start a new database at that specific point of time, what was the state, you can recover it. All these powerful features very well available as a part of RDS. Okay, free tier, as I explained, there are every service is available as a part of free tier. You can access this link and see what are all the things available at for what quantity. For example, S3, every month you can store up to 5 GB. 5 GB continuously, if you store for the full month, you will not get charged. But after that, you will start getting charged, and this is eligible only for the first 12 months from registration. After that, it will start charging. Okay, and these are all some additional rate points you have, like for example white papers. TCO calculator is to do some calculation upfront, how much it's going to cost for your organization by moving to Amazon. Okay, these are all the economics part of it. We have a separate session against the economics, but to give a quick introduction, this is again to do a calculation. If I'm going to use this or all the service, if I am going to use, how much it would cost. Okay, it's very beautiful links. Whenever you have some time, just go over them. And in the actual course, these are the things we will be covering. Okay, the module 1 will be introduction about cloud computing, AWS, different attributes, service models, everything we'll be discussing. And module 2, we will discuss EC2 and the EBS in detail. And module 3, we'll be discussing on the storage services like S3. S3 is simple storage service. Glacier is like backup and archival service. We'll be using them. And in module 4, we will be discussing that module 4 is dedicated for auto scaling and load distribution, elastic load balancer. Module 5 is identity and access management. Okay, it's got, along with that, we will be discussing relational data services as well. The module 6, we will discuss multiple AWS services, like around 6 services we will be discussing. Out of that, 2 you will have some demos, 2 to 3 services you will have some demo along with that. And module 7, we will discuss on AWS architecture, best practices, high availability, how to design the complete architecture within AWS, what are the best practices to apply, design patterns, everything we will be discussing as a part of module 7. And module 8, we will discuss final project, what are the projects you will be doing as a part of course completion, as well as the certifications, what are the different materials you can read, you can gain knowledge, further reading, everything, we will be sharing it as a part of module 8. This is how the course curriculum it goes. Every module it goes for around 3 hours. Okay. All right. Let me take some questions. First, let me take the questions from the question panel. Okay, Aishwar, horizontal scaling means adding new PCs. Yes, Aishwar, it's adding more and more PCs parallel to each other. Okay, does it support failover? Yes, different services, that's question from Ramesh. Different services, we have a different way to support failover. Okay, that's where the elastic load balancer, everything comes in. Your zones and regions will come into picture. And Nitish, any limitation for horizontal scaling? As such, no, Nitish. Your budget will be the limitation. Okay, the more number of instances, the more you will be paying, right? So budget will be the limitation. All right. What are the cloud? What are all the cloud computing, Aishwar, services other than AWS? There are a lot more things, Aishwar. In terms of IaaS, we have Rackspace, Google Compute Cloud, and in terms of PaaS, platform as a service, we have Microsoft Azure, Red Hat. We have an offering from Red Hat. There are multiple services players, but as far as I know, AWS is leading the show. I'm not marketing for AWS, but that's the fact. Okay, all right. Okay, okay. Nitish, like Flipkart, IaaS is down server time due to load. Are they not using any kind of horizontal scaling or cloud services? Yeah, they might not be using, or they would have restricted their scaling not to go beyond some limit. Right? Say, I can even have a restriction saying don't scale beyond 100 number of instances, because the more it's going to cost a lot, right? So I'll restrict, okay, I am okay with, I'm satisfied. I am not going to scale my infrastructure beyond this particular size because I am restricted to the budget. Yeah, Nitish, that would be the case. Okay, all right, Mithun, okay. Aishwar, like server sharing, can we install WordPress and other things? Yeah, definitely, Aishwar. If I have some time, I can quickly install a complete WordPress server, your complete infrastructure. There is some offering called CloudFront. We have some time, you can just go over that. Not CloudFront, it's called CloudFormation. The complete cloud you can create within few minutes. Your complete infrastructure will be up and running. Okay. Basically, all your settings will be there as a part of a configuration file. Okay, you can select whatever the WordPress blog, right? This is called CloudFormation. It's a very beautiful feature. The complete the details, how to create, what instance to create, everything I can mention it. It will be there as a part of a script. Your complete thing will be ready. If I do that, say I'm selecting a WordPress blog. Okay. Guys, I'm going to take another a couple of around 10 more minutes, okay, to answer all your queries. Okay, sorry about that. Sure. Okay. So what's the root password for my database? I'll give a root password T1 micro T2.micro. Okay, T2.micro is the I think I should give T1.micro. Okay, here you can give T1.micro and say next. Once you say create, your complete infrastructure will be ready for you. Okay, within few minutes. Okay, I get error. The page can't be displayed. That cannot be the case. Okay, let me just check. Okay, I hope you access this particular or like slash index.html. Okay, Ramesh, you're talking about, I guess you're talking about the web page. Anyway, I have posted that once again. Say I have another question from Samraj. I have medium instance. Is it possible to downgrade to micro instance? Yes, very well possible, Samraj. Yeah, that's very well possible. We are not going, it's only the compute power, everything, right? We can reduce them. But storage wise, it's a lot more things involved. For example, if you create a hard disk of say 10 GB and if you want to reduce that to 5 GB, that would be a little difficult. Okay, downgrading is not for very easy in terms of storage. Other than that, with the instance as such, we can do that. Vishnu, question from Vishnu. After the course, which certificates will I be able to do? AWS Certified Solution Architect, associate level. Yeah, Vishnu. Okay, I don't see any double authentication when login. So double authentication you can enable like a VPN. You can get a secure ID, or you can use Google Authenticator. That would be covered as a part of IIM Azure. That option is very well is there. Yeah. Okay, Bhaskar. Question from Bhaskar. Can you tell about what are all the kind of job profiles available in cloud computing? Example, DevOps, developer, testing point of view. See, job as such, it'll anyone who is using the cloud, definitely they will expect knowledge in the cloud infrastructure, right? If they are using now, a lot of organizations they are using AWS instead of going and procuring their own hardware, they are using AWS. So they'll expect a certification or an in-depth knowledge of AWS, how to use them, what to do, what are all the features they are talking about. So definitely in terms of DevOps, developer, as well as even production management, everywhere the job offering is there in terms of cloud computing. Okay, that's why I explained the initial slide. That's like five different people touching the elephant and saying what that is, right? It depends on the perspective and which job profile you are looking at. Okay. All right. In Azure, it allows private cloud that Microsoft hosts. In AWS, for private cloud, as customer needs to host. In AWS, we have something called virtual private cloud. It's called VPC. You can create your own network. You can add the instances, everything. What I was talking about is the physical private cloud. Okay. Same thing, Microsoft Azure also, whatever they are doing, the same thing is available over here in AWS. It's called VPC, Virtual Private Cloud, Ramesh. Okay, question from Aishwar. Can the instance handle a DOS attack? Okay, denial of service. Amazon is having very good infrastructure. Even they recommend, in case if you are doing any load testing or something, you have to inform them upfront saying it's not a DOS attack, it's only a stress test from your end. Okay, else what it will do, their firewall will catch and they'll stop all those requests from the specific region or IP. Okay, Ishwar? So they have very good infrastructure in terms of handling all those. That is the main reason, any if you're doing any stress test or load testing, you have to inform them well in advance. There are some formalities. You have to fill in the form and say this particular instance you're going to do stress testing from this particular IP or something. Yeah, sure. Okay, do you have any course where you tell how apps will begin? Cloud-based applications. Cloud-based applications design overall we will be discussing in terms of, in this particular course we will be discussing in overall as such how the application should be designed in terms of high availability, failure, everything. But specific to an application, for example, like a Google, any specific framework, no, this course doesn't cover. Okay. Will I get a certificate after finishing the course in Edureka? Yes, definitely, Aishwar. You'll get a certificate, it will be a verifiable certificate, and you will have 24/7 with global valid. Yes, they can verify it with Edureka whether you have completed, and certificate, it's not just a completion certificate. You will get the certificate after completing a project with Edureka, the final project with Edureka that will be evaluated with the team. So definitely that should make sure that having more value to the certificate, right? Yeah, it's not just by going over the material everyone is going to get the certificate, right, Aishwar? So definitely whoever is gaining the certificate means they have done the project successfully and they have in-depth knowledge. So definitely it will add value. Yeah, sure. Okay, how much time will be allocated to the project at the end? What kind of project will it be? Ramesh, after the course gets over, you will get around 2 weeks time. Like a real-time scenario, you will get 5 scenarios. You can choose one among them, whichever fits in as per your career. You can choose any one project. You can finish the project, and what should be the deliverable and what kind of deliverable you have to do, that will be given to you, and definitely support team will be assisting you in case if you're stuck somewhere, and support team as well as the instructor panel, they'll be in a position to help you. But definitely after going over the complete session of 8 sessions, that might not be the case. Okay, you will be in a position to do it on your own. Yeah. All right. Okay, will you give access to AWS instances, Manish, of a part of this course? No, Manish, you will be creating an account with AWS. Anyway, 1 year it is free, and whatever the limitation they are giving it, it's more than sufficient. You can practice for 1 year without even paying anything to AWS. But by default, what they'll do while registering, they'll block $1, but they'll not charge against you. That will get released. Okay, you need a credit card to get one free account with AWS. Okay, Aishwar, is there any centers in Chennai? All the courses are over the, it's online instructor-based training, Aishwar. Okay, physical center, no. Okay, I guess I have answered. Is Java language a requirement? Not necessarily, Ramesh. If you are from .NET background, all the .NET infrastructure, we can use it. Okay. Okay, Aishwar, I mean a physical center. Okay, what are the basics to learn the course? Basic, you should, if you have worked on any production or any projects for a year or two, definitely that should help. Okay, but as such, the basic knowledge on like initially how you have deployed, how you have worked on Java, .NET, that should be, even if you have knowledge on how the system works, for example, deployment, all those things, it works, that would help. Okay, is this meant for students or professionals? Definitely it's for professionals, Aishwar. There will not be any spoon feeding in terms of what is a load balancer. Okay, most of the profile, if you you can check with the support team as well, but if you look at the average profile, the average work experience, it will be around like 4 to 5 years experience. Okay, from 1 year experience professionals to 10 years experience professionals will be joining this course. And there are some statistics also very well available with the support. Yeah, the support team, you have the email and it's there as a part of Edureka website. They'll be in a position to help you with the statistics and get you the actual in-depth details on the prerequisites. Yeah, sure. Okay, all right. I hope I answered everyone's question. Is there any questions you guys have? You can just post it across if I have missed any questions, guys. Because I was going over, I made sure I went through all the questions. Okay. In case if I have missed any questions, please do post it. Don't hesitate. I'll definitely answer. Yeah. All right. Thanks for being the session, folks. Yeah. Thank you all. Thank you. Have a good day and good night.